Welcome to the workshop on Ethereum and smart contracts for the Construction Blockchain Consortium. We will be working through a series of examples on mainly Solidity, and at the same time, at the end of the day, you will have the chance to take a look at some of the prototypes we have been working with my colleagues Vasim Jabi and David Lombardi at the arcchain.cc project. My name is Theo Dounas, and I will be working with you through the workshop. I work at Robert Gordon University. I am the Learning Excellence Leader at the Scott Sutherland School of Architecture and the Built Environment, and I lead the ArcChain project for the past 2 years. The workshop is designed for novice coders, so people who don't have experience with yet with smart contracts or coding in general. So be patient. If you have already experience with smart contracts or any other kind of programming language, the language we will be using in this workshop is called Solidity, and we'll take a look at setting up an environment later on. We'll begin first by discussing what a blockchain is, and this diagram here kind of tries to portray the topology of a blockchain. A blockchain is essentially a new type of computer network where all nodes record a copy of the database, all of the information contained therein. Blockchains were invented to circumvent and solve some classic problems in computer networks. One is called the Byzantine generals problem, which resolves around how to record information and verify information in a network of nodes or a network of participants when you might suspect that some of these participants are malaligned and want to essentially corrupt information. The double spending problem is the problem of how you can actually when you have digital currencies, you can double spend if by sending a digital currency from one node to another, you do not essentially delete the sending transaction from the node that sends the currency. And this was solved essentially by creating the blockchains where each of those nodes would try to verify independently the veracity of the information for the next transaction. Currently, the most known blockchains are the Bitcoin blockchain network, which was created after the publication of the white paper by Satoshi Nakamoto almost 10 years ago, more than 10 years ago, I think, and the Ethereum blockchain that we'll be taking a look at today. Participants in a blockchain network can be very generally described between classified as miners. So these are the nodes essentially that participate in what I think very wrongly is called mining, which is the competition to verify the next block of information. Full nodes that each contain the full blockchain, and light clients that each synchronize part of the blockchain. Let's take a look at essentially how the chain of blocks is created. And you see here 3 blocks. Each of those creates the block, has a block header, which is essentially a description of the block and the number of the block. Each block has a cryptographic hash within it, a nonce, which is a random number which is used only once, a Merkle root, which represents the transactions that are contained within the block, and a timestamp, which is when the block was created. So essentially, the Merkle root is a hash that represents all of the block transactions that are recorded within, and this is generated by taking the transactions in pairs, hashing those, and through those hashes reaching a Merkle root. Essentially, the representation you see below is the representation of a Merkle tree, a tree of transactions. And this is a very nice mechanism of collapsing information into one piece of information, while at the same time having verification of whether a transaction is actually contained in the block. And this uses cryptographic algorithms. Search more on Merkle trees. They were named as such because of the Professor Merkle who created them, and they're a very interesting cryptographic mechanism to record information. Now, what creates the chain of blocks is that the block header of block is becoming the hash for the next one, and through cryptographic means, this essentially connects each block with the next one in an immutable manner. So you cannot delete essentially one block out of the chain without having the whole chain collapse. This allows you to have a distributed network, very much different to a centralized ledger. Compare this to, say, a bank where you have a trusted authority which verifies all transactions. And this allows also through the mining mechanism to have nodes competing and being incentivized to participate in the verification of the transactions. And through that incentivization mechanisms, you secure essentially the information on the blockchain. And here's a diagram of how a proof of work mechanism works. And you see here on top a representation of a blockchain, and in the smaller diagram you see 3 mining nodes competing for verifying the next block. This takes place by taking the previous header, using the, at least in the Ethereum blockchain, the ETH-hash algorithm, which is it contains essentially the SHA-3 algorithm, generating a 128-byte mix and comparing that with the pre-selected target the network has set. So each time a new block has to be defined, this is what the competing nodes go through to generate the new one. The first node, or the first pool of nodes that will actually reach the pre-selected target, is the one that will be awarded tokens of cryptocurrency, and that's essentially the incentive for participating. Through these mechanisms, essentially we have, as I said, the security and safety of the records on the blockchain. And these are essentially the recording of through a cryptographic hash of the previous block, and through the incentivization of the mining mechanism to, on a competitive basis, to record the next block, you secure the blockchain, along, of course, with the presence of a large number of nodes, right? So this only makes sense if you have enough nodes containing a copy of the blockchain. Here's a visualization of the Ethereum blockchain. This is on the Earth viewer, and you see essentially blocks connected between each other, and each one containing a colorful array of transactions, but also smart contracts. And we will get in a minute on what smart contracts is. But let's say that the initial blockchain of Bitcoin was created so that one was able to record addition and subtraction of information, essentially cryptocurrencies. But once you start thinking of addition and subtraction, then you essentially have mathematical functions, and if addition and subtraction are there, why not add division and multiplication? So essentially you start understanding that a blockchain can start behaving as a computer. And the way we can imagine a blockchain as a decentralized computer is if we start thinking that not only do we record transactions in terms of cryptocurrencies, but we can store their computer software in the form of smart contracts. The concept of smart contracts is essentially code that runs on the blockchain where it also stores information. If you combine well, why are they called contracts and not, say, computer code or computer software? Well, the combination of immutability and security of information within the blockchain, plus the idea that you no longer need to verify and trust participants, right? You can actually without actually asking for permission, you can create your own node and start participating in the blockchain, allows you to understand that the computational nature of how the blockchain is created allows the code that runs on it to be, let's say, secure and verifiable. Hence, it takes what might look like the form of a contract, in the sense that the way you set up the blockchain and the contract allows you to make certain that it will execute when certain conditions are met. Within the Ethereum blockchain, of course, you have also transactions on ETH, and at least on the top part of the diagram here, you see the miners of the last blocks, and you see the main pools of nodes that participate in the blockchain. If you want to know more about how these are created, take a look at ETH Viewer, and take a look also at the ETH hash algorithm on GitHub. But also you can take a look at the pools of nodes of miners that compete to create the next blockchain, the next block. So how can we imagine smart contracts to be, right? From a coding perspective, the whole of Ethereum is essentially a virtual machine. Imagine it as a computer, and smart contracts are classes of code that run on the EVM. And when we say classes, we essentially mean pieces of code that will be able to both store data but also have functions, so act on data stored within the contracts. If you take a programmatic perspective, right, so from a perspective of a computer programmer, this is the smart contracts are a digital protocol intended to digitally facilitate, verify, and enforce the performance of a contract, essentially a credible transaction without any intermediaries or third-party guarantees. In a very kind of classical understanding, the smart contract takes the place of law and vice versa by transferring part of what a legal contract would do onto the facility of the blockchain in terms of immutability, in terms of enforceability, and in terms of execution. Of course, this is all as good as the hardware and the software you run smart contracts on. we present this as a done deal, but actually smart contracts are as safe as the code you have written. So be careful with assigning too much security to the smart contract, in the sense that there are still flaws, and as all machines, the Ethereum virtual machine is not perfect. So one of the ways you can take a look at this is the classic incident at some point on the early development of Ethereum with the DAO, where a person was able to exploit a vulnerability in one of the smart contracts and be able to steal funds from the smart contract. And it took the agreement of all of the blockchain nodes to essentially reverse the transaction and fork the blockchain. So even though we say that blockchains are immutable and you cannot go back, we already have an incident where due to a software vulnerability, the whole blockchain decided to go back to another block and restart from there. The languages we're going to be taking a look at are Solidity, which is the main language most smart contracts are written in Ethereum, Viper, and LLL. Solidity is mostly like JavaScript. Viper is a Python-esque language, and it is picking up steam. And LLL is a Lisp-like language, which is now unfortunately depreciated. I'll take a look at the those docs, right? So if you go to solidity.readthedocs.io, you will be able to have an excellent manual of Solidity that will serve you really nicely if you continue learning the language. Viper is at viper.readthedocs.io. Same kind of deal, a very nice documentation. And LLL is located here. Be careful with LLL because it is at the moment depreciated and, from what I understand, no longer actively worked on. And we'll be back at the next lecture on environments, on how you can set up your own blockchain environment. Let me try to see if I haven't answered some of the questions. To basically create a Genesis block, you need to create a blockchain. So if you look online for setting up your own private Ethereum blockchain, what it does is immediately when you have two machines, you need at least two different computers to have a blockchain, because they will need to verify all data. The moment you launch them on one machine, that creates the first block, and it continues to generate one. In terms of the pre-selected targets that essentially most proof of work blockchain and algorithms work with, this is hard-coded in the algorithm. So this is decided by the programmers, and there is a whole range of philosophy around on how to do that and what is a good algorithm for that point of view. Be careful with proof of work, because most blockchains at the moment that are trying to be sustainable try to sift from proof of work to proof of stake, which is a different mechanism where you need a series of nodes to verify each transaction. Ethereum has already launched on an experimental level its proof of stake network, Ethereum 2.0, and there are a series of test networks that you can try with this. Don't test it yet with any kind of production system. In terms of the smart contracts having a legal entity, right? My answer would be I'm not a lawyer, right? You need to ask a lawyer on how a smart contract might be enforceable by law. So far, as I understand, people are looking into this within English or Scottish law. In particular, it is of interest with lawyers that work with construction law, but they're not enforceable yet. And in a private enterprise blockchain, who is doing all of the computations to validate transactions? Well, in a private blockchain, you need to set up the miners yourself. An enterprise blockchain is something different. It depends on the architecture that the enterprise blockchain has selected. But if we look at, say, a blockchain where you have lots of different participants, say 200 companies participating, it is via agreement on how they will set that up. Each participant, for example, could have their own node, or you could have someone else hosting a node for you.
Theo, in relation to how contracts are accepted, smart contracts can be accepted. So yeah, people are legislating for that to improve the acceptance and the enforcement. But of course, if you have a project and members of the project agree on the enforcement of the smart contract, then this becomes legally binding.
That's my understanding as well from colleagues that are lawyers, and we're working on seeing what the framework is. If you have a legal contract that assigns responsibility of enforceability on the smart contract, then that becomes legally binding, as with any other legal agreement. Are there any other questions on the introduction so far? Okay.
So yeah, that last question from Sagaho. Are there any initiatives by UK government to support blockchain in construction contracts? Yes, and this is to do with the cross-parliamentary group on blockchain. So I'm a member of that cross-parliamentary group, and we'll be discussing this tomorrow. And also the administrator of the the cross-parliamentary group will be presenting, I believe tomorrow, the day after. Fernand will be presenting, so to discuss that. So there are some initiatives. This is mainly led by the CBC in collaboration with the cross-parliamentary group at the Parliament.
Any other question? You can raise your hand or just unmute yourselves and or type.
I can go ahead with the next video, perhaps. Oh,
Yeah,
here we go.
I think so.
Are hash and blocks similar?
No. Essentially, hashes is a series of information of a specific length to which you reduce all other information. So you will need to read a little bit more on computer theory in terms of what cryptographic hashes are. Blocks, well, how many blocks can be in a chain? We don't know that yet. You could have infinite, depending on well, you cannot have infinite actually. Depending on the size of a storage that you can provide. So that's how many blocks you can have, right? So as many as it can fit inside the storage you have on each of the nodes. Blocks contain many other types of transactions, and you need to look into Merkle trees and see how you don't have an equation where you look at one transaction equals one block, if that's what you were looking for, but essentially a block contains a series of transactions.